I'm going to talk to you today about my work on suspended animation. Now, usually, when I mention suspended animation, people will flash me the Vulcan sign and laugh. But now, I'm not talking about gorking people out to fly to Mars or even Pandora, as much fun as that may be. I'm talking about the concept of using suspended animation to help people out in trauma. So, what do I mean when I say suspended animation? It is the process by which animals deanimate, appear dead, and then can wake up again without being harmed. Okay, so here is the sort of big idea. If you look out in nature, you find that as you tend to see suspended animation, you tend to see immortality. And so, what I'm going to tell you about is a way to tell a person who's in trauma to find a way to deanimate them a bit so they're a little more immortal when they have that heart attack. An example of an organism or two that happens to be quite immortal would be plant seeds or bacterial spores. These creatures are some of the most immortal life forms on our planet, and they tend to spend most of their time in suspended animation. Bacterial spores are thought now by scientists to have existed as individual cells that are alive but in suspended animation for as long as 250 million years. To suggest that that's all sort of about little tiny creatures, I want to bring it close to home. In the immortal germline of human beings, that is the eggs that sit in the ovaries, they actually sit there in a state of suspended animation for up to 50 years in the lives of each woman. So then there's also my favorite example of suspended animation. This is sea monkeys. Those of you with children, you know about them. You go to the pet store or the toy store and you can buy these things. You just open the bag and you just dump them in to the plastic aquarium, and in about a week or so you'll have little shrimp swimming around. Well, I wasn't so interested in the swimming. I was interested in what was going on in the bag. The bag in the toy store shelf where those shrimp sat in suspended animation indefinitely. So these ideas of suspended animation are not just about cells and weird little organisms. Occasionally, human beings are briefly deanimated. And the stories of people who are briefly deanimated that interest me the most are those having to do with the cold. 10 years ago, there was a skier in Norway that was trapped in an icy waterfall. And she's there for 2 hours before they extracted her. She was extremely cold, and she had no heartbeat. For all intents and purposes, she was dead, frozen. 7 hours later, still without a heartbeat, they brought her back to life, and she went on to be the head radiologist in the hospital that treated her. A couple of years later, so I got really excited about these things. About a couple of years later, there was a 13-month-old. She was from Canada. Her father had gone out in the wintertime. He was working night shift, and she followed him outside, nothing but a diaper. And they found her hours later, frozen, lifeless. And they brought her back to life. There was a 65-year-old woman in Duluth, Minnesota last year that was found frozen and without a pulse in her front yard one morning in the winter. And they brought her back to life. The next day, she was doing so well, they wanted to run tests on her. She got cranky and just went home. So these are miracles, right? These are truly miraculous things that happen. Doctors have a saying that, in fact, you're not dead until you're warm and dead. And it's true. It's true. In the New England Journal of Medicine, there was a study published that showed that with appropriate rewarming, people who had suffered without a heartbeat for 3 hours could be brought back to life without any neurologic problems. That's over 50%. So what I was trying to do is think of a way that we could study suspended animation to think about a way to reproduce maybe what happened to the skier. Well, I have to tell you something very odd, and that is that being exposed to low oxygen does not always kill. So in this room, there's 20% oxygen or so, and if we reduce the oxygen concentration, we will all be dead. And in fact, the animals we were working with in the lab, these little garden worms, nematodes, they were also dead when we exposed them to low oxygen. And here's the thing that should freak you out, and that is that when we lowered the oxygen concentration further by 100 times to 10 parts per million, they were not dead. They were in suspended animation. And we could bring them back to life without any harm. And this precise oxygen concentration, 10 parts per million, that caused suspended animation, is conserved. We can see it in a variety of different organisms. One of the creatures we see it in is a fish. And we can turn its heartbeat on and off by going in and out of suspended animation like you would a light switch. So this was pretty shocking to me, that we could do this. And so I was wondering, when we were trying to reproduce the work with the skier, that we noticed that of course she had no oxygen consumption, and so maybe she was in a similar state of suspended animation, but of course she was also extremely cold. So we sort of wondered what would happen if we took our suspended animals and exposed them to the cold. And so what we found out was that if you take animals that are animated like you and I, and you make them cold, that is, these were the garden worms, now they're dead. But if you have them in suspended animation and move them into the cold, they're all alive. And there's a very important thing there. If you want to survive the cold, you ought to be suspended, right? It's a really good thing. And so we were thinking about that, about this relationship between these things, and thinking about whether or not that's what happened to the skier. And so we wondered, might there be some agent that is in us, something that we make ourselves, that we might be able to regulate our own metabolic flexibility in such a way as to be able to survive when we got extremely cold and might otherwise pass away. Thought it might be interesting to sort of hunt for such things, you know. And so I should mention briefly here that physiology textbooks that you can read about will tell you that this is the kind of heretical thing to suggest. We have, from the time we are slapped on the butt until we take our last dying breath, that's when we're newborn to when we're dead, we cannot reduce our metabolic rate below what's called a standard or basal metabolic rate. But I knew that there were examples of creatures, also mammals, that do reduce their metabolic rate, such as ground squirrels and bears. They reduce their metabolic rate in the wintertime when they hibernate. So I wondered, might we be able to find some agent or trigger that might induce such a state in us? And so we went looking for such things, and this was a period of time when we failed tremendously. Ken Robinson is here. He talked about the glories of failure. We had a lot of them. We tried many different chemicals and agents, and we failed over and over again. And so one time, I was at home watching television on the couch while my wife was putting our child to bed, and I was watching a television show. It was a television show, it was a Nova show on PBS about caves in Mexico. And this particular cave was Lechuguilla. And this cave is incredibly toxic to humans. The researchers had to suit up just to enter it. It's filled with this toxic gas, hydrogen sulfide. Now, hydrogen sulfide is curiously present in us. We make it ourselves. The highest concentration is in our brains. So, yet, it was used as a chemical warfare agent in World War I. It's an extraordinarily toxic thing. In fact, in chemical accidents, hydrogen sulfide is known to, if you breathe too much of it, you collapse to the ground, you appear dead, but if you are brought out into room air, you can be reanimated without harm. If you do that, if they do that quickly. So I thought, wow, I have to get some of this. Now it's post 9/11 America, and when you go into the research institute and you say, "Hi, I'd like to buy some concentrated compressed gas cylinders of a lethal gas," because I have these ideas, see, about wanting to suspend people. It's really going to be okay. So that's kind of a tough day. But I said, there really is some basis for thinking about why you might want to do this. As I said, this agent is in us. And in fact, here's a curious thing. It binds to the very place inside of your cells where oxygen binds, and where you burn it, and that you do this burning to live. And so we thought, like in a game of musical chairs, might we be able to give a person some hydrogen sulfide, and might it be able to occupy that place, like in a game of musical chairs, where oxygen might bind, and because you can't bind the oxygen, maybe you wouldn't consume it, and then maybe it would reduce your demand for oxygen. I mean, who knows? So, there's a bit about the dopamine and being a little bit, what's called delusional, and you might suggest that was it, but